Hello guys, again and welcome back to our class in ESci132, your mechanics of deformable bodies. And now, we ended up our lesson having a question about reinforced concrete. And reinforced concrete, we realized that that one is a composite body. So therefore, maotong nag-topic ko og composite body so that we can go to our topic reinforced concrete. And how are you going to apply that transformation using metal bars and concrete? So that will be our goal for this topic, to be able to apply our flexure formula by the composite reinforced beam. So usually, a reinforced concrete beam has a cross-section wherein its height is longer than its width. Kaya mao man dyan na usually, di ba nga itong mga beams, para mas dako siya og moment of inertia. Okay? And, however, your concrete alone is not good in tension. And di ba we have learned dito sa atong bending a topic that ang atong mga beams, kung applyan mo moment, above the neutral axis na siya'y compression, and below the neutral axis there is a tension. But concrete again is only good in supporting compressive loads, but it is very bad in supporting tensile loads. So that is why concrete beams are usually reinforced with reinforcement bars, or your rebar or your steel bars. And usually these reinforced steel bars are placed below. Ganun dili sa babaw, because sa babaw compressive ang gisupport ana. So concrete is very good at that. But diri sa ubos sa atong neutral axis tensile, so ang atong rebar ang nag-support sa tensile nga load. Okay? So mao nang importante. Ingana ka importante ang imong rebars. So assuming you already knew kung asa dapit ang neutral axis, let's say maoning neutral axis, wala na'y gamit ang ubos aning atong concrete. Okay? So ang ato lang gi-consider diri is ang kaning atong baba nga portion sa concrete, and then ang rebars. Again nga no, kay ato na ni siya gi-assume nga ni crack na ang ubos sa atong neutral axis sa concrete nga beam, kay di ka support ang atong concrete og tensile load. So we assume nga wala na ni siya gamit. Ang nagpugong lang or ang nag-stop lang ani into fracture kay ang atong kaning reinforced beams. Okay, so mo lang nato i-consider. So how can we transform this rebars into concrete? So basically, ang ato lang gihapon buhaton is to have that transformation factor N, in which your N right here is now equal to, di ba, we want to transform your steel into concrete, so therefore, we will expect nga mas mudako ang area ng atong steel. So therefore, nasa numerator ang atong steel? Modulus of elasticity of steel over the modulus of elasticity of your concrete. Okay? So therefore, instead of just changing the width siguro ani, di ba kaya ang atong gibuhat kagani kay ang width atong gi-change. Pero instead of ang width ang atong i-consider diri sa atong reinforcement bars, ang area ang atong i-consider. Ang area ang atong i-change. So, to get your new area, ato siya himuon og area sa imong steel multiply by N. Okay? And by transforming this area sa imong steel into this one, mao ni ang mahitabo. So, mao na ni ang nahitabo. Ato gi-convert ang katong area sa steel into an area of concrete. And now this is your NAST. Okay? And this distance right here is your D. And let's say the distance right here is your B. And the problem we have right now is we still don't know sa distance sa neutral axis. And let us solve for the distance of the neutral axis. And let's call this one as H prime. Okay? From the top ta sa diri sa babaw, padong diri sa neutral axis. So, ang atong buhaton karon, mag-moment ta sa aning duha ka area nato about sa atong NA. Okay? Di man ni nag-moment ta. So, atong buhaton, A times Y chuchu. Sa Y chuchu, mo ang centroid sa atong area. Okay. So, unsay may tabo? Base area aning rectangle times H prime. Unya moment about sa atong neutral axis, this is H prime over 2. Di ba? And then kaning isa. So, located man siya ubos sa atong neutral axis, that is negative, times area which is NAST, still multiplied by the distance which is D minus H prime is equal to 0. And therefore, you can solve for the location of the neutral axis as B over 2 H prime squared minus NA still H prime minus NA still D is equal to 0. So, muna equation. This is the equation to get the location of your neutral axis. And by that, you can solve for C, you can solve for I, and you're good to go. Since this one is now already homogeneous. Okay? So let's have this example. So we have this reinforced concrete. Gana itong reinforced concrete. Sa ubos ani niya, na gi-reinforce diri ang duha ka 1 inch diameter nga steel bars. Okay? And there is a moment applied diha nga portion of 60 kip feet. And also, gihatag dira ang atong modulus of elasticity sa atong steel as 29 times 10 to the 3 KSI and sa atong concrete as 3.6 times 10 to the 3 KSI. So we are going to solve for the normal stress of the steel reinforcing rods. Okay? And also the maximum normal stress of the concrete. So, unsa atong una buhaton? Since this one is not homogeneous, we should make this one homogeneous. But before that, we should put a neutral axis. Ang kanang neutral axis, wala pa takibawa nga distance. But let's say, this is H prime. Okay? And, mauna ni siya ang itabo. Kaya diba, your concrete doesn't support tensile, so, matanggal na siya, and then, mauna lang na ang nahitabo. This is your concrete, and this is your steel. But the problem is, they are not yet homogeneous, so we have to transform this one into concrete. So how are we going to transform this one into concrete? Pangitaw na tong N, and pangitaw na tong area sa steel. So to get the area of the steel reinforcing bars, since duha man na sila, so ato times 2, pi times 0.5 inch squared. Diba? And that is 1.571 inches squared. So that is the area of your steel bars. And we are going to convert this area of steel into an area of concrete. To get the area of concrete, so that is E steel over E concrete. So therefore, 29 times 10 to the power of 3 divided by 3.6 times 10 to the power of 3. Multiplied by the area of steel, which is 1.571 inches squared. And therefore, the area of the concrete is equal to 12.65 inches squared. So, kani, at na-convert na nato, nahimo na siyang ing-ani. Tingnan na siya. And this area is 12.65 inches squared. And kani, mo ni atong pilay distance ani. Di ba gihatag to nga 18 ang distance ani and this is 2 inches. Gikan diri pa dong sa center ani. So that is 16 inches. But still we don't know this H bar, which is the location of the neutral axis. So we have to look for the neutral axis, the location of the neutral axis. To get the location of the neutral axis, ang ilang button is magamit itong moment about neutral axis, area moment. So, unsa man to? That is, this one is 12. So, base, which is 12 times height of H plus times location H bar over 2. Sunod, minus, mani? Area, which is 12.65 inch squared times location, which is 16 minus H equals to 0. And by getting the positive root of this one, because this is squared, you will get that your H bar is equal to 4.85 inches. So therefore, this one is 4.85. Okay? So, nakuha na nato. So, we can solve for MC over I. Diba? Okay, let's do this. Sige. But before tamo ato sa MC over I, ato sa ni pangitaon nga distance. Diri padong diri. That is 16 minus 4.85. 11.15. Probably we will use that one later on. Okay. We cannot use yet MC over I because we have to look for the moment of inertia. To solve for the moment of inertia, sa to button, about the neutral axis, okay? So, this is BH cubed over 12, which is base of 12 times 4.85 cube over 12, diba? Plus the area, 12.4.85 cube multiplied by the distance of 4.85 divided by 2 squared. Ano gi-cube ni nako? And then, sa kaning atong area diri, wala man siya based og height. So atong button lang kay ang area niya, which is 12.65 inches squared multiplied by the distance, which is 16 minus 4.85 squared. And we will have an answer of 29 inches to the fourth. So take note, kung area ra ang gihatag sa imo, wala kay base og height, mo lang ni imong gamiton A times D squared. Okay? Therefore, 2029. So, Flexure formula, the maximum bending stress of your concrete, which is maoni maximum, is equal to M, which is pila tong moment ni mong gi-apply, 60 keep feet. Pero since inches man atong gipang solve, so we have to convert this one as 1 feet, 12 inches. Multiplied by C, which is this one, 4.85. Kaya ba ang maximum man sa concrete atong gipangita? So, mo man yung maximum sa concrete. Kani kaya man yung maximum sa concrete. Okay? Over 29 inches to the 4. So, therefore, that is equal to 1.72 kilopounds per square inch. And now, pila man ang stress nga naa diri. So we also have to solve for that one. Ato butangan og prime because we still have to transform this one back into its steel bars, di ba? So this is magyapon 60 kilopound feet multiplied by 12 times, instead of 4.85 ato na igamit karon kay ang 11.15 over 29 inches to the 4th. And you will have an answer of 3.96 KSI. But take note, this stress is ang stress pa ni sa concrete. Wala pa ni siya gi-transform into steel. So we have to transform this back into steel. So therefore, the stress in steel is equal to ang concrete nimo multiplied by N. Okay? And that is 3.96 times 29 times 10 to the power of 3 divided by 3.6 times 10 to the power of 3. And you will have a final answer sa imong steel as 31.9 KSI. So, mo na yung mga final answers. Mo na yung sa steel nimo, and then mo na yung maximum sa concrete. And, sige, ato i-draw ang profile view, ana. So, mao na yung imong concrete nga beam. Ako lang butang ang tanan. And then, mao ni ang imong reinforcement bars. Okay? And then, this is your neutral axis. So, ang nahitabuan ni, na kay compressive stress dira. And ang maximum kaninga point is 1.72 KSI. And then, wala na ni tensile stress ang dere sa ubos, kaya ang atong concrete di mo support with tensile stress, and ang ato lang steel ang nag-support. And ang imong steel, nag-support siya og tensile load of 31.9 KSI. Okay, so, ing-ani lang. Dali siya, probably. But if you have questions nga, naglibog pa mo unsa unto, then it's good to practice and read references. Okay? So, ani lang ka sayon pag-solve og composite nga mga beams, especially reinforced concrete beams. So, as a summary of all the lessons that we have dealt with today, we already knew how to transform a material into another material by using our transformation factor. And we already knew that Flexure Formula can only be applied once the material is homogeneous, and we can determine the normal stress of a composite material that is subjected to bending. So I hope nakasabot lang mo sa to lesson, and next meeting is our last module. Mao lang to for this day, and thank you for listening, and see you again on our next class. Bye!